All right. Okay, that's fine. So yeah, welcome.
Thank you.
It's really great to have you here, Sylvain.
Yeah.
I mean, we were reminiscing one. You were at UCLIC, weren't you, doing your postdoc?
Yeah, a while ago.
A while
Almost
ago.
10 years ago. Yeah.
No. No, I think it was only 2 years ago.
Okay, let's pretend it was 2 years ago.
2 years ago. And then we had a period of overlapping quite a lot when you first went over to Lille. You had a grant together, which was really nice, with Nick Marquardt as well. So yeah, I'm really looking forward to hearing about this line of work here around recall. And I think it's kind of stuff you got started with Andy Coburn, right?
Yeah, exactly. Like basically some sort of long-term work that I've been doing periodically, but for like a 10 years period. So I would present papers that were as old as 2013, I think.
I look forward to hearing about it. I'll hand over to you now. So thank you very much.
Okay, thank you very much for the introduction. So as Duncan just said, I'm Sylvain Malacria. Really nice to be here today. I will give this talk where I will discuss a little bit about, do we need to rely on recall for having efficient interaction when interacting with graphical user interfaces? But before that, so I'd like to introduce myself a little bit more. So as Duncan said, I used to do a postdoc in London at UCL between 2013 and 2014. And right after that, I had a Inria research position, a permanent position in the research center of Lille, which is situated at the northern tip of France, as you can see here, at the crossroad of 3 main European cities that are Brussels, Paris, and London. And it's actually really, really close from London. Like you could almost commute if it wasn't for the price of Eurostar, because I basically took a train this morning that took me 1 hour, 20 minutes to come to St. Pancras. So it's really, really quick to come, really convenient. And I'm really, really happy to be here. It reminds me what I miss from London. I'm now part of a research group that is called Loki and led by Stefano. I'll just give a brief introduction about it. So we're 7 faculty members in the research group, and we have 10 PhD students and 1 intern, 2 engineers. And I really, really have the pleasure to co-supervise or supervise 5 of these PhD students with which I explore various research topics. And hopefully 1 more, UCLIC, our intern, hopefully will continue with a PhD soon. And one specificity that we have is that we collaborate a lot with Canada. I have like 2 PhD students that are co-supervised with people from University of Waterloo. I also co-supervise a student with Vincent Lambert with people from University of Grenoble. So that's something that I love to do, collaborate with people that are not necessarily from my research group. So if one day you're interested in anything that might be in my line of work, don't hesitate. Or if you want to chat after that, don't hesitate. Overall, I will describe my research profile as an interaction and system designer. I have always conducted research that would not be too technology oriented. I don't like my research to be driven by a specific technology. I've always been more interested by, I would say, higher level interaction design interest, even if it might sound niche when I will talk about it. And even though it will sound as a broad description of HCI, I'm really interested in how people communicate, how interaction is communicated and mediated. So first, communicated from the user to the system, how we can design systems so users are able to accurately specify what their intentions are with the system. But also how interaction is communicated from the system to the user. I'm currently the PI of a research grant that is specifically investigating how we can refine graphical user interfaces so they're better exposed to user what can be done with these interfaces and how user can interact with the systems. And more recently, I've also started to explore how interaction is communicated between users themselves. So how basically they share their knowledge about how to interact with systems, how researchers communicate about interaction they design through visual depiction, and also how users tend to rely on tutorials and how we can help to produce better tutorial when you want to explain someone how to use a system. But yeah, today I will focus on probably what I've been working since, the longest, as I was saying. I think the oldest project I will present today is 10 years old now. And it will be about all the work I've done on some difficulties that users face when they are exposed to an interactive system they are not necessarily familiar with and they actually want to interact with it. and how they will acquire skills when trying to interact with this system. So overall, skill acquisition is complex and far from being perfectly understood. But however, it can be simplified as follows. So generally speaking, regardless of the activity, skill acquisition is usually described as following that type of law and being correlated with practice. So that's what we call the power law of practice. And basically performance will improve over time. And regardless if we're learning to play a music instrument, a new sport, usually at the beginning, you don't know anything. So you progress a lot, then you know a little bit more, you start to decrease in terms of learning rate. And at some point you reach your performance cap until you have like a plateau. Actually, if you continue longer, then you lose capacities like as a human and your performance tends to decrease. But it would be too easy to always approach any problem using that curve. So let's take another example. Look at cycling, for instance, how to learn to ride a bicycle. A common approach to learn to ride a bicycle is to add training wheels like this at the back. So you basically put training wheels at the back of a bicycle of a child, for instance. So the child feels confident on the bicycle. So can sit on the bicycle, pedal, steer using the steering wheel, the steering wheel, and feel confident on it, okay? But training wheels limit performance while cycling because basically, for instance, you cannot steer by tilting the bicycle, modifying the balance. So you really have to slow down when you're turning and that type of things. So basically you improve with a bicycle, but you reach a relatively low plateau of performance with the training wheels. And for getting better, teachers, most often the parents, will remove the training wheels from the bicycle, which will create a problem because the learner hasn't improved at all on one of the most important aspects of learning how to ride a bicycle, which is that basically this is velocity that gives you balance. So when you remove the training wheels, you have basically a dip of performance like this one, temporary, but quite consequent. And after a certain time, the kid finally learns how to ride the bicycle without the training wheels, and so we're good. He or can she can improve while riding the bicycle. And interestingly, user interfaces have a similar problem, in their design, similar situation actually. Interactive systems either provide interfaces explicitly designed for novice users that are really, really easy to approach because everything is displayed, but rely on certain paradigm of interaction that might be slow, like pointing on graphical widgets. Or interfaces more for experts that are harder, maybe longer to learn, but once you master them, you can be highly efficient. And a typical example of that in user interfaces is command selection. When you want to select commands in an application, you can have interfaces more for novices or for commands that you're not familiar with, that you will select using the mouse, for instance, by clicking on widgets, and more for experts that you will select either by using a keyboard shortcut that you will have learned beforehand or a gestural shortcut. So the notion of transitioning from this novice mode of interaction that relies mostly on clicking on widgets to the expert one faces the same problem of performance dip. Okay. And because command selection can be simplified as a time that you take to select a command, I will actually flip the curve like this. So now the problem is slightly different, but basically it's exactly the same curve, except that we use command selection time rather than practice to describe the system. So we have two main modes of interaction, one more for novices, one more for experienced users. And one is mostly based on recognition, like you will visually recognize what you can click on the components. And the other one based on recall that will require you to have learned something beforehand and recall it to be able to perform this shortcut. So this is called the intermodal expertise transition problem. And this context comes with several issues. So as I was saying, to begin with, users have to be aware of the faster interaction method. If they're not aware of it, we cannot expect the user to transition from the novice one to the more expert one. And this time there's no parent around to tell you, okay, remove the training wheels. Now you have to switch to the more efficient one. And even if users are aware of the faster method, sometimes they will not transition. Okay. They will not make this switch, and they will not make this switch even when aware for several reasons. First, it's called the problem of satisficing. So satisficing is a portmanteau of satisfy and suffice. And it basically describes users that may find their performance with the novice method efficient enough, so they don't really see the point of switching. It's okay. And second, because of a problem called the paradox of the active users. It can be described like this. So basically, users who would benefit the most from the most efficient interaction technique, the one that are really intense into their usage of the software, are simply too engaged in their activity to consider making an effort, an explicit effort of learning the most theoretically efficient way to interact with the system. So the question here was, how can we encourage users to think about that performance? Okay, how can they think about, okay, maybe I can do better while interacting with the other interfaces? So the drastically different approach that we explored was to stop asking too much from user and stop blaming them for not switching. So we're not expecting them to do it without further instruction. After all, they could be afraid of making errors. They could maybe not see the benefits at all to transition. So, and they cannot be blamed because they have no way to estimate the cost of making the transition. They have no way to estimate the benefits of making the transition. So they shouldn't be expected to transition. So this is what we explored in a first project I will present. So that was called Kilometers and was done during my first postdoc while I was in New Zealand. With Joyce Carr and Lee Cockburn, Carl Gotwin, there is a typo on the slide, and Toby Grossman. And basically, we came up with this concept of kilometers that are simple reflective widgets that are meant to motivate and help the user to increase their level of performance. And kilometers are a generic concept that we describe in the paper that I will not describe in detail today, but they're targeting 4 specific design goals in that respect. The first one is to show to the user that there is possibility for improvement, okay? Show to the user in a way that there is room for being better. Then find a way to motivate users to improve, either using gamification or using a social basis or anything that could be used to motivate the user. Then providing details on how to improve, trying to help the user to find a way to better understand how this improvement could take place. And finally, trying to minimize as much as possible the real-time interaction from the user. So we don't face the problem of the paradox of the active user that will feel like he or she had to interrupt their task to improve. And applied to command selection, and more specifically to the intermodal transition problem, we came up with this hotkeys kilometer. So the hotkeys kilometer is a small widget, so it was not large like this on the display. You'll see after that, but it has 3 main parts. Basically a bar chart. The bar chart shows the last command selections. The height of the bar is how long it took to select the command. The color is what modality was used. It's red if it was a mouse, green if it was a keyboard shortcut. And the bar overlays the name of the command and possibly the keyboard shortcut, the corresponding keyboard shortcut. Below the bar chart, there's a sentence explicitly stating how much seconds could have saved, like an estimation of how much seconds could have been saved by using more keyboard shortcuts. And on the right, a meta reflects how you position compared to a certain social scale and your coworkers or something like this. So in that respect, it was necessary, actually, I didn't want to keep these slides, but it was necessary just to, the hotkeys kilometer I described was working in a certain macOS application. I developed it as a background application that was working. And in order to make it work, we had to estimate how long it took to select a command in the menu. So we used Mayer's model for that. Basically, when a menu was open, we were coming back in the previous pointing trajectories, trying to identify the source of the ballistic movement, estimating how long it took to open the menu. Then we add the time to select the command, and boom, we add it in the bar over there. That's more the correct side of the hotkeys kilometer. It could be moved around the interface, it could be reduced, and it was becoming slightly translucent when no commands were selected. So basically, every time a command was selected, you had a new bar adding, and so every time it was animated like this. If it was using the mouse, you could see the red bar. If it was green, you could see the green bar. So that was pretty simple. And to see if it encouraged users to switch to command selection, we ran a study like this where we basically participants were interacting with a keynote slideshow. And in this keynote slideshow, they had some comments to select. And we had two groups of participants. One had the hotkeys kilometer and the other group didn't have the hotkeys kilometer. And what we could observe is that so there were repeating blocks of interaction, and that we could see when we were looking at the proportion of commands that were executed using either the hotkeys, the toolbar, or the menus. That participants that were given the hotkeys kilometer, so on the right, switched earlier to keyboard shortcut and eventually used almost twice as many keyboard shortcuts than those without the group. So what we could see that in addition, they switched earlier and possibly learn more hotkey thanks to the hotkeys kilometer. So they're encouraging, but remain preliminary. Unfortunately, I was developing, as I was telling you, like a hotkeys kilometer that was working in the system. And then Apple decided to update macOS and lock a little bit of the OS. So I must confess, I gave up on running the field study, unfortunately. But yeah, they were still encouraging in making us realize that you can encourage users to switch to a more expert mode of interaction. But there's still a problem. They were still using keyboard shortcuts, and there is still this, even if we encourage them, they still have to memorize the keyboard shortcut when they want to use a keyboard or gestural shortcut. And memorization is difficult and recall prone to errors. So what we wanted to do, no, actually not what we wanted to do, but I'm going to present like just another work that someone has done before that. That is specifically targeted at making recall more implicit in a way, which is a technique that lots of you will probably already know, but I will introduce it anyway, just in case some of you don't know it, which are marking menus that were introduced in the early 90s by Gordon Kurtenbach and Bill Buxton. So marking menus are gestural shortcuts or gestural menus that are displayed around an activation point like this. And if you want to select a command, rather than clicking on a menu item, you basically draw in the direction of the item you want to select, okay? If it's a submenu, it opens a submenu, and you keep going on like this until you reach the command, release your finger, and then you have a mark that corresponds to the command you wanted to select, okay? And if you already know the gesture, you can perform it instantly. So what is great with marking menus is that they implement the principle of rehearsal. What it means is that you're learning through rehearsal. Unlike command selection on desktop computer, where you will select commands by clicking in menus using the mouse, and then using a shortcut on a different modality, a keyboard, here it's the same modality. So if you're in novice mode, you wait for the menu to appear, you perform your gesture. Once you've memorized the gesture through muscular memory and repetitions, you can do it instantly. Yet, memorization still rely on, the commands still rely on an arbitrary command gesture mapping. And so this mapping, because of arbitrary decisions from the designer, might be hard to memorize to some extent still, because there's no mnemonic. So we wanted to see, can we get rid of this arbitrary command gesture mapping to try really to help users recall again or more easily the commands. So we try to reintroduce mnemonics to facilitate memorization and reduce the performance dip thanks to that. So this is something we've done in a project called Augmented Letters that was done with colleagues from Telecom Paris, where I did my PhD at that time. And the idea behind Augmented Letters is really simple. Rather than relying on abstract gestures only, what we will do is we will use the first letter of the command as the beginning of the gestural shortcut. So basically, if it's a command save, you start by drawing S, and then you have a marking menu with much less commands and a directional tail to select the command. So you have less things to remember. You have less arbitrary direction to remember because the first letter of the command is pretty easy to remember. So that works like this. Let's say you want to select an arbitrary command that starts with M. You draw M, the menu appears, and then you have the directional tail. And if you want to select the same command, just draw the corresponding gesture, and that's it. Similar to marking menus. So augmented layers still capitalize on the principle of rehearsal, which is using the same gesture in menu mode or expert mode. But now memorization relies somehow or to some extent on the mnemonic mapping. But augmented layer might be longer to draw because they're much longer to actually, simply longer than simple directional gesture. So we wanted to test the benefits or drawbacks of augmented layers compared to marking menus. We did that in a memorization study. The protocol used a succession of learning and test phases. So during learning phases, participants could display the menu so they could see what are the commands. And during test phases, we were asking them to select commands, but they couldn't reveal the menus. They had to try the gestural shortcut, whether they knew it or not, regardless of if they had memorized it. And so we've divided the command selection time during these test phases in two. So first reaction time, which is the time between when we ask participants to select the command and when they start drawing the gesture. And then drawing time, when they start, when they're actually drawing the gesture on the surface. And if we sum up both, we can see that it took approximately the same time for marking menus and augmented layers, because thanks to the mnemonic mapping, they had like a lower reaction and recall time with augmented layers. And in the meantime, they had a higher recall rate with augmented layers, thanks again to this mnemonic mapping. So compared to marking menus, augmented layer reduced the performance dip through less errors and easier recall at no speed cost, which is nice. But still, this is not the full picture yet. This is where really I started to flip the way I see things. Because regardless of the method applied to try to encourage users to switch or to try to minimize the performance dip, there is still a transition at some point, and this transition can be a problem. And we still have one mode of interaction relying on recognition and one relying on recall. And this recall, for me, is important. So with that in mind, I just would like to comment. So what do you think these four animals, that is a chimpanzee, a hamster, a honeybee, and myself have in common? Okay. One thing is that we're all known for having a really bad memory. I have a bad memory. I'm struggling to remembering things. I'm struggling to remembering where things are located and so on. So I did reflect a lot on this framework. And at some point, I was like really wondering, is the recall mode necessary? Do we need to ask to the user, okay, make the effort to remembering things and explicitly learn things? Or can we have something that would be like this? Just like almost the perfect learning curve, maybe not as great in terms of performance at the end, but at least more smooth and less demanding to the user. And my approach is that I think that if we want to do this, we need to get rid of recall and try to get back to recognition-based interaction techniques only, or at least try to avoid explicit learning and recall from the user. So the question now is, are interaction techniques that do not require explicit memorization necessarily bad? Because that's what designers have been saying for years. Like if you permanently showing things to user and cluttering the interface, it will be bad. So this is something we explored in several projects. One was conducted with Jay Anderson, Mathieu Nancel, and Edward Lenk. And in this one, we investigated the necessity of delay in marking menu invocation, the interaction technique I showed you earlier. So I showed you that marking menus are displayed, this is a circular menu, are displayed after the user dwell on the surface after a certain time, okay? And why was it designed like this? So in his PhD manuscript, Kurtenbach argues that marking menu, if systematically displayed, can be distracting, can obliterate part of the interface, that displaying the menu takes time, and that if basically you add delay, it may encourage users to use mark mode, so the mode without the menu, which I find interesting because if you display it instantly, then you don't have any mark mode, so you don't need to encourage users to use something that doesn't exist. But still, that's one of the arguments that he's made. And in his work, he characterizes interaction with menu and mark mode like this. So basically, estimation of the time taken is like when you want to select a command while displaying the menu, or like the marking menus, first your pen enters in contact with the surface. Then you wait, typically 1/3 of a second. Menu takes 1 frame to display. Then users react. Oh, okay, it's displayed now. User does some visual search to then move to select, and finally release the pen to select the command. While in expert mode, you simply put the pen down, move, release the pen, and that's selected. Okay. But in the end, the main difference is in the delay itself, because the time it takes to display the menu, the time you wait, and so on will be important in how long it will take for the user to select a command. So if we come back to this curve, actually, it's likely that the time difference that we have here is mostly due to delay. So that's what we wanted to test. And we had the following hypothesis regarding a marquee menu that would have a single mode that would systematically display. So we contrasted one marquee menu that systematically displayed to the default one. Hypothesis were that lower command selection time overall with a marquee menu that systematically display. That the systematically displayed marquee menu would have a lower error rate than the default one because it does not rely on recall. So user can always see the commands they're selecting, so they shouldn't make as many errors. That command selection time would be lower with default marquee menu when practiced, but because trained user will still wait for the menu to appear. And that the no delay marking menu will be visually disruptive and obliterating the interface. And we tested this hypothesis. Oh, sorry. We tested this hypothesis in these 3 studies. So I will not detail the studies here because it will be too long. But in short, what was interesting is that we found support for H1 and H2. So delay does significantly impact the cost of marking menus. Okay. So when you had the delay, overall, the command selection time will be longer because people will systematically wait for the commands they don't select frequently. And we, however, found mixed results for H3. So in study 1, the first one that we didn't observe any benefit for the default marking menu. We didn't observe any benefit even for practice users. So what we did a study where participants had only to select 2 commands. So they were really, really overtrained with 2 commands. And we finally started to see a slight difference between a menu that is always displayed or not, but like really with a small effect size. And what's really interesting is that in study 3, we didn't find any evidence that it was visually disrupting. We had like a really, really highly visual task where people had to arrange some comic strips and things like this. And it wasn't a problem at all. People just got used to the menu displaying, and at some point you just bypass it. So it suggests that if we do not impose this delay and use a single mode marking menu without delay for novice interaction, user can reach almost the same cap of performance that with a conventional marking menu, except maybe for commands that are selected really frequently, for which we have like a really small difference. But for all the other commands, it was systematically better to not have a single delay. But this better performance is reached more easily with less errors and less frustration. So a method that is not based on recall may be viable in the context of command selection with marking menu. And so we explore this as well on conventional graphical user interfaces with keyboard shortcuts again, in another project that was conducted with Gilles Bailly and again, Carl Gottwin and Andy Cockburn and Joel Harrison. So in this one, we explored something similar about keyboard shortcuts. Nowadays, if you want to use a keyboard shortcut, how does it work? Basically, if you want, you first need to know what the keyboard shortcut is. So let's say it's a toolbar like this one. You will need to locate the widget you want to use a keyboard shortcut with, and you will move your mouse pointer over it to reveal the corresponding keyboard shortcut. And that's when you're lucky, because nowadays system less and less reveal the keyboard shortcut in the tooltips of that type of buttons. Then you will switch your attention back to the keyboard, and finally you will perform the keyboard shortcut. But the thing is that command selection was 1 click away of being completed at this stage. So people simply don't wait to reveal it. It's really an explicit effort to reveal the keyboard shortcut and learn it. So we are like, okay, maybe if sometimes you want to select a keyboard shortcut because you have your hand on the keyboard, you should be able to reveal the keyboard shortcut using your keyboard when basically it's needed. Pretty simple idea. So we came up with expose hotkey, really simple. Let's say you have a modifier key. You want to select the keyboard shortcut corresponding to that widget. You simply press your modifier key on your keyboard. Up, it reveals all the keyboard shortcut of the interface. And okay, that's Command T. You press Command T, and it's done. And so we adapted it to toolbars, menus, ribbons. We have like one experiment for each in the corresponding paper. I will not detail all the studies, but we run few of them, and one of them was comparing basically the usability of expose hotkey compared to what was the baseline at the time, an audio feedback, basically saying Control J when you were selecting a command, whose corresponding keyboard shortcut was Control J. So it was like a feedback after selection. And what we could observe is like, yeah, of course, when you reveal the keyboard shortcut, people can easily use the keyboard shortcut. It's displayed. Why wouldn't you be able to do it? You just press the modifier key, then, oh, okay, Command J. I type Command J. So really rapidly, they reach a high percentage of hotkey usage. And we conducted a second experiment, focused this time on command selection time and comparing it to other types of command selection. Either mouse pointer, either other command selection that is relying on the keyboard, like the Alt key tips that you can have in Microsoft application, where you press Alt and then a series of characters to traverse the interface and select the command using the keyboard. And so once again, selecting the command using expose hotkey was faster. So at first, it's not faster than pointer, but from block 3, it was faster than pointer to eventually reach 30% faster than the other techniques in the last block. So once again, if we make an efficient interaction technique that does not rely on recall, that might seem somehow visually cluttering, it's still working, still efficient, and people can select commands fast and without making mistakes. And for expose hotkey, we made the arbitrary decision to overlay a hotkey on its corresponding button. And we actually used several methods to do that. But there's not always space for displaying it. Okay, sometimes we display the modifiers, sometimes we didn't. But if you have like a really, really crowded interface with lots of buttons, you might run out of space to display this. Which is why we worked on this fourth project called Icon HK that was conducted with Emmanuel Giannisakis, Gilles Bailly, and Fali Chevalier, where we explored how icons from toolbars could be used to communicate how the keyboard shortcut should be performed, okay? How they could encapsulate this knowledge so you don't have to wait for a tooltip to appear, for instance. So the idea behind Icon HK is as follows. Let's say you have this button and this keyboard shortcut, okay? So a keyboard shortcut is always a combination of modifier keys and a character key. In order to communicate the modifiers, we use the corners of the button, okay? And we map each modifier key from the keyboard to one of the corner. So let's say it's Control that is involved in this keyboard shortcut. Then we fill the corresponding one. And then for the letter or the character, whatever, you just put it somewhere. It's displayed on the button. So you transform the pictogram and letter to blend them into one icon. So this is an example of an icon HK, icon that permanently conveys both the keyboard shortcut and the meaning of the command. Yet we came up with different strategies in how it can be designed in the button. So we have this first strategy that I just showed you, empty space. You put the letter where you have the space, or you make the space for it. Positive space that basically relies on salient feature of the icon to somehow support the character, and negative space for some icons that might have a negative space that can be used to communicate the character. And then you can imagine that for each of the design, you have a magnification continuum that will translate or animate, interpolate between just the icon or just the letter. You can imagine that for all of the strategies. And it could also be emphasized when you press a modifier key, just like for expose hotkey, using any type of animation. So in that case, it's a feed-forward similar to expose hotkey. So you can display the default icon when the user is not pressing a modifier key and emphasize a keyboard shortcut when needed. Or it could be emphasized as an adaptive interface based on users' habits. So if you're selecting the commands always using the keyboard shortcut, system assumes that it's known, so you don't have to emphasize it. And the other way around, if you're always using the mouse, it could reveal more later, so user might be more exposed to it. And so once again, we connected the study to test whether user would be able to understand first that icons are used to communicate keyboard shortcuts, and if they could recognize the hotkey just by looking at the icon, even when it's not emphasized at all. So just like previously, we used an experiment that alternated between training and test phases, okay? During the training phases, participants were asked to say command using the toolbar or keyboard shortcut. And participants saw a toolbar with buttons like this. So basically, it was icon HK icons with the letters that was slightly, that was emphasized. It was displayed on the button. Plus a control condition, obviously, that wasn't showing the keyboard shortcut at all. And during the test phases, participants were seeing just icons like this without having any sort of emphasis of the keyboard shortcut. And participants were asked to perform the corresponding keyboard shortcut. If they didn't know it, they had to try anyway. And we also perform a recall test 24 hours and 72 hours after the experiment. So the results of this study revealed two groups. Basically, first group is control and empty space. Okay, and you can see the vertical axis is retrieval rate, correct keyboard shortcut during test phases. Second group was positive and negative space. And what's really interesting is that user was still able to retrieve 100% of the shortcuts with positive and negative space, even 72 hours after the test. So that means that they had remembered the encoding that the designer put in the buttons, and they were able to retrieve the corresponding keyboard shortcut by just looking at the icon. And finally, participants spontaneously discovered the principle. And that was actually really interesting because they discovered, oh, there's like these highlights on the letter that is actually the corresponding keyboard shortcut. And then they used it to try somehow to create a mnemonic, even for some of the groups where it wasn't intended to reveal it. So they just created a cognitive process where they were trying to memorize keyboard shortcut like this. So expose hotkey and icon HK show that without recall needed, it still can provide interesting and efficient interaction techniques for conventional graphical user interfaces. And now we'll talk about the last project of this presentation, which is what is the context of more conventional menu bars and not of more conventional, like of soft keyboard shortcuts, sorry. Which is basically all the keyboard that now we have on touch-based devices, okay? How does it work for selecting commands on touch-based devices? Because now it's becoming a big thing. What's interesting is that command selection on touch-based devices is far from being as standardized as desktop interfaces. As a result, and possibly because of the limited screen real estate when designing the first interfaces, it is often tedious to select commands. You have to open a menu or navigate in hierarchies, just like on the menu bar, to select command. And what's interesting is that it's not consistent across applications. It's not consistent across platforms either. As an example, let's say you're actually looking for a specific string of text in Safari on iOS. So there are several ways, but one of them is to tap the share icon, then slide the menu that it opens, because it makes sense to have like lots of commands in the share menu. And tap on the Find on Page button that is located in the share menu, because still that makes sense. And you enter the specific string you're interested in, and then you can locate it. On the other hand, if you go on Chrome and Android, you have like a kebab menu, as it's called. And in this kebab menu, you have a Find in Page, and then you tap Find in Page. So it's not consistent. It's not, and you have several ways to do it. And sometimes it's a bit tedious. On the other hand, as we saw, we have like more standardized ways to interact on desktop computer. And one of them I talked about and that I like are keyboard shortcuts. And why don't we have keyboard shortcuts on touch-based devices? Okay, we don't have a permanent keyboard. Well, but is it the only reason why we cannot actually use keyboard shortcuts? So interestingly, in previous works, I was really, really naive about it. And for some reasons, I did write things that now I may regret in introductions of some of my paper, which were basically like either thus miss common input resources like the physical keyboard on touch-based devices for entering text, performing hotkeys, or in FastTap in 2014, where we wrote that the lack of physical keyboard means that there are no keyboard shortcuts for quick selection of touch-based devices. But does it mean that because it's a soft keyboard, we couldn't use keyboard shortcuts? No, I'm not sure of it. There is a keyboard on such device. It's just not permanently displayed. It could be accessible most of the time, but like since the first iPhone, there was already a keyboard. So the main difference is that it's not permanently available, but only there when you need to tap text, but that's not a major problem. So why would it make sense to have touch-based keyboard shortcuts? First, it would provide a quick access to command selection in text-based apps, because there is a keyboard in text-based apps, so we could use it. Because it's soft-based, it could be reconfigurable, so it's easy to display commands on top of the soft keyboard. It's even better than on the desktop because my physical keyboard cannot be adapted. So it displays keyboard shortcuts. You can buy stencils that work for some applications. That's what they do for video editing platforms and that type of things. But like, it cannot be dynamically updated on the physical keyboard. It can on the soft keyboard. It could exist in non-text-based app as well. You just need to have a button to open it. And it can optimize skill transfer because you might learn keyboard shortcuts from the touch-based device and transfer them to desktop interface and the other way around. And actually, it exists in some platforms, but it's pretty obscure. It's not really, really widespread. And it relies on, once again, no standard, really, really different implementations. So you can find it on some Samsung Galaxy tablets, also Microsoft Surface tablets, and it's always implementing something different. For instance, I think the left is a Samsung Galaxy tablet. Basically, you have a control key, and when you press the control key, it highlights with a color keys that have commands associated, but that's it. It doesn't tell you which commands, and it doesn't do it for all the commands. On the other hand, Microsoft Surface displays here a tiny text, but it's using a different type of mode. So it already exists on touch-based display, but not really systematic. It's limited to text entry context. And design aspects and performance remain unclear, like what type of input. Should it be like user maintain mode? Should it be like a non-user maintain mode? Is it performant? Is it discoverable? And that's lots of questions we explored with colleagues from Singapore University of Technology and Design in the soft cuts projects. And how does it work? So what we did is we basically designed soft keyboard hotkey system that works like this. You just have a button similar to a modifier button, and when you press it, it reveals the commands, display the icon, the text, and that's basically it. And in application where you have text, you don't have text, you just have like a translucent button that you can press, like the accessibility button that you can add on iPhones, for instance, and you can use it for selecting commands. So we run like 4 studies in this project. I will not describe all of them, obviously. I will focus on one that was how the command mappings affect user learning, because I really wanted to see if a mapping where users were highly trained with, so where they already did explicit learning, would be beneficial or not, to see if basically this recall was useful or not. In this study, we compared 2 mappings for softcuts. The first one was a realistic one, basically using real keyboard shortcuts, so B for bold, X for cut, and so on. The other one was a completely abstract one where we put some flags for countries, and that was it. And we tested performance and accuracy for participants. And interestingly, in terms of accuracy, we found like a significant difference, but with a very, very small effect between both. So accuracy, realistic, they made slightly more errors, but that's it. Almost 100% of accuracy, no errors, regardless of the mapping. And in terms of performance and comment selection time, it was also comparable with only a very minor difference of 5% with the recognition-based technique. So it was pretty comparable. Even knowing the mapping beforehand, you could see that it barely helped in terms of learning. During the first 2 blocks, maybe you're slightly under, and here it's mostly noisy. And if you look actually just as a stable performance, you don't have any significant difference. So these 4 different projects, they really suggest that it's viable to provide comment selection mechanism that are efficient without asking users to memorize beforehand anything, and without requiring them to recall what they may have learned. And as a result, it is less likely to result in error. And above all, it leaves cognitive resources for other aspects of the interaction where it might be more useful. So maybe recognition and displaying information as training wheel is not so bad after all, but actually in the end, it may not be training wheel. It's just like something that is well designed, and rather than requiring recall, it's still working. So even if requiring recall might in the end be useful and beneficial in terms of comment selection time for commands that you select really, really frequently, in the end, there are lots of commands that we don't select that frequently, where having a recognition-based system that is still efficient might be beneficial for users. So the way I see it, the 4 systems that I presented there are more than training wheels. And even if they're training wheels, some people can become eventually expert at training wheels. So maybe that's what we want. We just want to have training wheels that are not limiting the user in terms of performance. And all these methods, what they would mean if we don't want to require explicit memorization and complex recall. In my opinion, it doesn't require that much. What it means is that we will have maybe interfaces that are visually cluttered like this. Yes, it's scary. It's scary at first, it's scary during 5 minutes, and then our brain bypasses it, always. It's exactly what we do with the world. It's like if you look at what kids with hyperactivity, ADHD, hyperactivity disorder do, it's what they learn to, it's what they cannot do. They cannot basically bypass some signals from the environment, from the world. What we do is we're able to bypass lots of signals, and that we know what we can ignore, we know what we have to look at. In an interface like this, we know what we have to look at and what we don't, when it's not blinking and moving all the time. And it's even easier when it's transient, when the user is in power of calling it by pressing a key, like it was in exposure key, icon edge key, and so on. And even if it's disturbing at first, it's just like the first few minutes when interacting with the interface. Then people get used to it. That being said, I must recognize that recognition is less and less what drives current interface design. Current interface design in commercial products is really driven by making things as neat and as light as possible. It might be because I'm completely wrong, and in terms of design, it's better. It might be because it's less scary for the user, and what actually matters to these people is that they're able to sell product that people will play with when they walk in a shop and interact with it during 5 and 10 minutes. So I completely agree that it's what I'm saying today is going against what most commercial products are doing. But yet that's what I start to believe really, really strongly in my core. And nowadays, these systems, they hide so much that they even hide like how you can interact with it. They have features such as when you can use force, when you can use gestures, motions of the device, they're not revealed anymore. They hide components all around the interfaces. And the only way to know it is either to go on a specific website, look presentation videos, information is less and less conveyed via the interface. But we know that most users do not read manuals that are less and less provided with devices, by the way. They used to be provided. Now it's like you don't even have the instruction manual in the box when you buy a product. It's like, go online, go read. And most people actually don't do that. So that's why I have like something, projects I will not call, I didn't talk about today, but like MPI over grant that is focused on how we can communicate interaction to the user, as I told you, because as Dilbert like cleverly illustrate here, it's like you don't fix a bad user interface with manuals. If you want it to work better, you actually improve the user interface. So before to conclude, I would like once again to thank all of my co-authors. As you noticed, I love to collaborate with people. I've collaborated with UCLIC people recently. I mean, former UCLIC, because it was mostly Nick that left like a few months ago, but I really like this. And then I wouldn't have done like any of this project if it wasn't for them. I especially would like to honor the memory of Edward Lenk, who tragically passed away a year ago now, and had basically been working in our research group for 4 years, like since 2018, and it was a true mentor. He was a true mentor to me. I learned a lot with him, and we miss him dearly. Well, that was my talk. Thank you very much for your attention, and I would be happy to discuss and answer any of your questions.
Thank you. Thank you. Questions, comments? I've got the microphone here. If you could lead on that, that'd be great.
Yeah. I can pass it.
Oh, you can pass it around.
Thank you. Really interesting work. I could get off on a tangent about the fact that small wheels in the UK for kids' bikes are a no-no these days. So like that's more of a pub conversation. It's really interesting work. I was wondering whether you look at all into longer term effects. I think you mentioned briefly like a field study that you were thinking about.
So that's the thing. I need to. The honest researcher answer is I need to do it. I really have to do it. What happened is that every time I've tried to implement something in a system has been like, I'm not sure how to say in English, but like updated and preventing ways to inject code in applications. At some point, I had like a version of Skilometers working in the system. There was an update, basically crashed everything. I had my Inria position at that time. I had to kickstart everything. I gave up. Then had like a fantastic student implementing an exposed key version that was working in real application. And that's when macOS implemented the system integration process, I think, SIP, that basically prevented lots of code injection and things like this. So we basically, to find participants, we had to find participants that were willing to restart their computer in safe mode, enter a specific command in a terminal, and so it was impossible. What I really have to do, and I've been trying to see how to do it. So I downloaded the OpenOffice source code recently, and I'm trying to look at how it could be integrated in one application rather than making all applications, and then trying to distribute one of this app. So right now I'm focusing on expose hotkey because it's probably the easiest one to implement. It basically only requires to be aware of the command shortcuts and detect a modifier key press. So I'm trying to look at how it could be implemented in this app and run a long-term application.
Thanks.
Long-term evaluation, sorry.
That's really interesting because yeah, I'd be interested to talk also about the technical issues. What you describe of like the system being modified and then you becoming locked out, it sounds familiar, not in recent experience, but a long time ago I was banging my head a lot against that kind of issues. But more in general, do you feel that like this longer term evaluation would be sort of like valued? Because obviously you lose a lot of control. I'm no longer very familiar with this part of the HCI community. So I asked the question in a very naive sense, in the sense that like I can see potentially reviewers complaining about the fact that if you do long term, then you can no longer measure performance in the same way as you do in your controlled studies.
So so for several answers to this question. The first one is I don't necessarily value results of my research on whether reviewers will value it. I know it's important, but if it's research that is not, it's really important for my students because I need to publish. When it's my project, a little less, but I completely understand what you mean. It's less controlled. So how can you value command selection time? Obviously, but what we used for the Skilometers, the pointing model I described, was proposed. Basically, it was implemented in a tool called the Mouse Input Observer. That was published at WIST in 2012 or something like this. it's supposed to be relatively accurate in measuring how long it takes to, in terms of motor control, to select a command. So I think it can be valued, and especially because there's almost no long-term study on command selection. I think if you come up with one that was deployed on a real application, it has to be valued by reviewers in a certain way, because it's always what we pretend we will do in future work. Like future work, yeah, we should do a long-term study, but we often lie to ourselves when we pretend we will. And once again, today, it's something that has always been in my mind. I have a folder called long-term exposure key on my computer in which I dump things occasionally, just like, because as you say, it's not necessarily valued as much. It's probably why we don't do it really, and I haven't done it yet.
Well, there's also like technical challenges, so it's
not the other one, because I'd love to have it for myself. So I'd love to be able. That's why actually I wanted to have like a working version system-wide, because I wanted to use for myself. And now I moved to OpenOffice, even though I never use it, because it seems like the more realistic way.
Yeah, that's interesting. Thank you.
For a certain target audience.
Now I've got a question online here from Nancy. And so Nancy says, thank you, Sylvain, for a totally fascinating talk. Really interesting and clever designs. I'm sorry I couldn't come in person today, but I'd love to connect and discuss more in future, and I'll send you Nancy's contact details shortly. I'm really interested in your icon hotkeys work, which really shows that we can communicate a lot of information in a simple visual design. Here's the question. How far do you think we can go in terms of the amount of information we can communicate through visual designs? So what's the upper limit here on the visual bandwidth? In the studies you've discussed, the focus is mainly on hotkey commands, which is a single behavior. Do you think your findings could be equally applicable in cases where we are trying to educate people on a sequence of behaviors? For example, an ideal workflow, the best order to execute different functions, et cetera, et cetera. So scaling up to more complex things.
That's a really interesting question, really challenging one, I think. I'm not so right now. Currently, I have like several projects that are trying to communicate different types of interaction within either graphical buttons appearance. That it might be touch-based interaction, like performing swipes or force press or dwells on a single button, how we can encapsulate it. So already trying to encapsulate and maybe communicate several different types of inputs. Same for micro gestures or that you perform with a hand. I haven't approached and reflect at all on sequence of actions. I think it's highly interesting, highly challenging as well. But I'm sure there might be ways to visually encode sequence of action. Then the question is how much effort it will ask the user to actually recognize what you've encoded visually, and whether they do it spontaneously or if they need help. For me, that's the following question. I think it's possible. Lots of things are possible to do graphically. We can cover a lot.
Thank you. I'm just going to throw in one more question. This is my question very quickly. So you've talked a lot about hotkeys around graphical user interfaces. And of course, 5 years ago, we had all this stuff on voice interfaces as a series taken off. That's just another form of shortcut, right? I mean, what are your thoughts on, everyone got excited by voice user interfaces until the bandwagon move on. So what's the issue? I mean, they didn't really stick, did they?
So I love a bit of anecdotal stories, but I started to use voice user interfaces a while ago, and at first I wasn't using it at all. And in 2017, I severely broke my right hand, my dominant hand. So like, hey, let's try how we can use it. And there are like really, really good aspects. So basically I used it almost exclusively during 6 months. And there are like really, really positive aspects and downsides to this. So what's good is that, in terms of accessibility, it's fantastic. The problem was it's a bit slow, hard to discover what you can do and what you cannot do, and really, really hard to recover from errors. That was the problem. I don't see it really as a shortcut. I see it as a technique that is highly efficient in situations where you cannot use your hands. As soon as you cannot use your hands, now I use it. Now I stick with it. But basically, I'm walking. I'm almost never taking my phone out of my pocket. I'm using Siri a lot, except Siri is often asking me, you need to unlock your phone to do that. And so, so in that case, I have to use my hands. But if I didn't have to unlock my phone for that, if it was basically recognizing my voice, I probably would use it as much as I can when I'm walking in the street and things like this. Then in terms of, I would say, productivity work, it's too slow to browse what you can do and even to recognize what you can do, because you need to have a list of what is achievable. So that's a bit complex. Yeah. But that being said, the voice user interface community is probably the only one or the main one that has tackled the problem of discovering what the user can do. Like studying, okay, do people actually discover what they can do with the voice and how it can be communicated? So that's really interesting. I have a lot to learn from that community about that.
Excellent. And us here.
Thank you, Sylvain.
Thank you.
I wanted to ask you about different user groups.
Yeah.
So I was curious about your participant groups for these studies that you presented. And I was also curious whether you'd ever considered, for example, the gestural mnemonics for user groups such as visually impaired persons, or the animations for user groups such as younger children.
Yeah.
Yeah, thank you.
Thanks for your question. So that was like a bit the easy solution for me, is that all my scenarios are articulated around productivity office workers. So thanks to that, it's mostly adults used to interact with computers. I acknowledge it could have been, I could have investigated things with people with visual impairments or things like this, because there are lots of productivity workers that suffer from visual impairments. But I was mostly interested in people working on computers, so getting computer science students and that type of things. It would be really, really interesting, but I think actually sometimes we could discuss this if you're expert in that domain. I'm definitely not, so I will not make any assumption, but maybe animation can be useful to help users notice things in the interface and that type of thing. So maybe it could be helpful in certain ways, or even like it would be interesting to see how Icon HK could be iterated on to maximize the recognition for people that suffer from certain type of visual impairments. Because if you look at the negative space or positive space things, obviously it wasn't designed with people that might suffer from chromatic dysmorphia or something like this. So we were not thinking about it, and that would be really, really important to think about that type of population if we wanted to scale the system. But my population was mostly people without visual impairments or any specific impairment, and definitely used to interact with computers. Thank you.
Thank you.
Thank you for your interesting topic. I think I need to recall an efficient interaction. So I'm interested in the line and the
curve.
Yeah. I'm very interested in a line, and I can see is the interrupt the different line. Yeah, could you please?
You want me to show them?
Yeah.
I'm gonna take which one? This one?
Yeah.
Oh, this one. Yeah.
Yes, I think it's practice, and it could improve the recall. And is this a relationship about recall and recognition? Yeah.
So there is somehow, I mean, depends how we define recall and what we encapsulate in recall. I may have slides that we did during the soft cut, the last project. We had a study where we basically looked at if people could remember the location. And what's interesting is that even though for the realistic mapping, they could basically look at the key. Okay, so they knew which key it was, they already knew, but even if they didn't know, they had like a memorization of the area on the keyboard where the key was located. So even if they were looking not at the exact command, their gaze was always going towards the area where the command was located. So it's not explicit memorization, but it's still recall because it's spatial memory. And this recall helps recognition because it helps visual search. Once they know where a command is located, they go more rapidly. And so thanks to that, the recognition is faster than when you have to browse the interface like this with your eyes. So that's how it's related, I think.
Thank you. Another question, sorry. I think if recognition could improve the recall,
Yeah.
so is there any interrupt is big?
I don't know that. I mean, the only example where we really have recognition that helps recall that we had was icon HK, where basically they had icons like this. And once they noticed that the shape of the arrow was referring to an A, even if you don't show the A, they were able to retrieve it. But it's hard to quantify really the effect size of it. I mean, the only thing that we had was that basically, I'm just coming back to the result for this project, was basically that when you don't have it, it was 100% against 75%. But if we want to know the exact effect size, we would need long-term studies to see how it decays for both of them. Do they almost forever remember what it is as long as we prime them frequently enough? And does it remain stable here, or will it decrease sometimes if we want to quantify it? Otherwise, I'm not sure how it could be quantified, the effect size.
So it's a good point is test 4. You said test 4 is 4 times or 4 times.
There was like first learning phase. They were practicing once. They did a test.
Yeah.
Practicing again, test again. Practicing again, test again. Practicing again, test again. From now on, no more practice. Just test, and test.
Okay.
So they weren't practicing anymore. The only practice that there was seeing it, but we weren't telling them if they were correct or not. So they didn't have any confirmation.
Okay.
So
thank you. Thank you very much.
Yes. Thank you for that. I just had a quick question. Did you notice that there were any hotkeys that people really struggled with learning? And if so, what it was about those hotkeys that they struggled with?
So most of the time, what I had as a feedback was actually hotkeys that involve several modifiers. And often because there's like no logic behind, I mean, not a strong logic behind the modifiers that are used and the command itself. So sometimes it's just like, okay, we need more hotkeys, so let's add control in addition of command or something like this. And Apple has guidelines about how to use the modifiers. Like if you use a shift key in addition, it's supposed to be for larger scope of the command. So like, I don't have an example like this, but like if command P is print and you want to print all documents, it should be command shift P. So their guidelines are to implement this logic, but in practice, it's not the case. So that's what they struggle the most for memorization, but also for performing in terms of finger coordination. I mean, that's what was reported, but we didn't run any strong studies about it.
Okay, great. Any other questions? Good. Thank you very much.
Fantastic. Thank you.